Alright, what's up guys? Today we are going over the Side-Splitter Theorem. So what I'd like you to do, just take a moment, try number one, take a look at number two, see if you can do them. Alright, I'll pause and wait for you guys. Okay, pause it, really do it. Okay, try number one, and then two. Alright, so now you tried number one, we're able to do it. If not, let's talk about how to do it. So what did you notice about these two triangles? Well, first of all, you should have noticed they have two angles equal, and they also have these vertical angles that are equal. And if these two angles are equal, it means that these lines are parallel because they're alternate interior angles. They make our z. So these angles are equal, and now we know that the triangles are similar. It also says they're similar right there. If they are, then what we should know is that these sides are proportional. So for example, if we know that UW is 10 and UJ is 5, then we know there's a 2-to-1 relationship between the sides. So if you want to do a proportion, you can do 5 over 10 is equal to, let's say we're going to find y. We're going to do y over the corresponding side, which is 18. And then we can solve. So 10x is equal to, 10y is equal to 90. We can divide out and get that y is equal to 9. You also could have noticed if it's 2-to-1, that means the smaller one is half of the bigger one. So if this is 18, half of that's 9. And the same thing goes here, right? I can do, let's do 10 over 5 this time. And then we're going to do x over 4. So we'll do 40 is equal to 5x divided by 5. And get 8 is equal to x. If you do want to use the scale factor, just make sure you state the scale factor is 10 over 5 or 2 to 1. And then you can literally just do 4 times 2 over 1 is equal to do 18 times a half is equal to, and then you should be able to kind of go about doing it that way. Number two is a little bit trickier. All right. We know that BD is parallel to AD, and what we're going to do is I'm going to take a time out in a second, but I want to set up this question. And I know that I have certain parts of this, like I know that this is 12, 15x, and 3x plus 8. Now I want to find the length of AC, which is this entire side. So what I can tell you is that this entire piece is x plus 12. Okay, let's pause. Go down here to the Side-Splitter Theorem first, because we're actually going to use this to kind of go about doing the rest of the number two there and then the rest of the worksheet. So in the Side-Splitter Theorem, we have a line that's drawn parallel. It cuts through two sides, and it's parallel to the third side. Okay? And what this does is it tells you that it divides the sides proportionally, which means that it's kind of like top over bottom here, right? RQ, which is the top, over XI, so bottom over top. Remember, we can flip this around, right? So we can do RQ over XR is equal to QS over SY. We can just flip that fraction over. Tissue time out. I'm not feeling well today, so. And then what we're doing is we're doing the top over the bottom. Okay. So the top part here over the bottom, top over bottom, bottom over top, same type of idea here. The other option is we can do the whole, right, to the top or whole to the bottom. So well, it's usually just a whole to the top. So we can do it that way as well. We're going to talk about this in a second, though. But what we really want to notice here is because these are drawn parallel, that these angles here are congruent because they are, see if you can think of the vocab word there, corresponding, right? So those sets of angles are equal, and they're also sharing this angle Q, which tells us a couple things here. Number one, that by drawing that line in, what I'm actually doing here is creating two different triangles, right? I got this one on the top right here, one on the bottom. Okay, and then one on the bottom. So actually, by drawing the side-splitter theorem here, I'm showing that triangle QRS is similar to triangle QXY. And then we can just use all the proportions. So the top for the hole on this side, top to the hole here, or the bottom to the bottom. So we start getting these ratios. And once again, you can like flip this over. So let's go back up to number 2. And if we see that these lines are given as parallel, then we can identify the two types of triangles going on, right? We have this top triangle here, okay? Then we have the whole big bad triangle right there. And so what I can do now is I can create a proportion. So I can do 12 over x plus 12 is equal to, so remember it's small to big, so we'll do 15 small over big 3x plus 8. And so when we cross multiply, right, multiply both sides by x plus 12, and then both sides by 3x plus 8, we get 12 times 3x plus 8 is equal to 15 times x plus 12. And so we distribute 36x plus 16 carries 1, 96. Okay, get out of here.
Okay, I'll bring the bird away.
15x plus. Okay. And then we do the same thing.
Oh, that's making.
And then we get 180 here. Alright? And so we're just going to get all the x's on one side first. And so get 21x is equal to, and then likewise, subtract 96 from both sides. Divided by 21, we should get x is equal to 4. And so we're looking for the length of AC. Remember the AC is equal to x plus 12. So we get AC is equal to 16. All right. So let's go down and let's do a couple of these, and then I'll move on to the next page, the next part. So find the values of x, and then the length of MP. So what we're going to notice here is we have, we don't have the entire triangle, the entire bottom triangle. So this is going to be like top to bottom here, right? Okay, so it's going to be 12 over, we have x plus 1. Then we have 9 over x. We can cross multiply itself. So 12x is equal to 9x plus 9. Remember to distribute, right? 9 and then x plus 1. Take away the 9x, you get 3x is equal to 9. Divide out, we're going to get x is equal to 3. And then we want the length of MP, right? So remember, if we plug 3 in for this, we're going to get KP is equal to 3 plus 1, which is equal to 4. So MP is equal to 12 plus 4, which is equal to 16. You don't have to show all that work, but just keep in track that that's what you're trying to do. Same thing for number 2. And you can see it's the same setup for number 3, right? Top to bottom, top to bottom, top to bottom, top to bottom. So it's the same idea as you guys are working on those ones, all right? We might want to do is kind of try to catch, let's catch a one that's not the same. So figure below, we have the triangles are similar, which means that these are parallel. Okay, we have AB is 7, BC is 8. If AE, this entire side is 4, DE is 16, and we want to find CE. So we want to know what that piece is here. Okay, so what we're going to do is we're going to make a ratio here. Now, if this is x, because this is what I'm trying to find, then this is really like 4 minus x. Okay, so you got to keep in mind as you're doing that one, what's going on here and how to do the setup. So if you know the length of this, you know the bottom piece, we can do 4 minus x for that one. So we'll do the same setup here, right? So I have this small triangle here, top, I have values of, I have 7. Well, now I have 4 minus x and 8. So now this 7 really I don't need because I don't have anything else on this side. So when I try this one, and this is the special case where I have the triangle on the top, triangle on the bottom instead of cutting the sides proportionally. So keep that in mind. If they give you either one of these sides, you got to use the small triangle to the big triangle. So this is going to be 4 minus x over 8 is equal to, we want right to bottom, so we're going to go right to bottom again. Okay, cross multiply. So 16 times 4, 64, minus 16x is equal to 32. Take 64 away from both sides. Get negative, keep in mind the minus sign stays with it. 16x is equal to negative 32 divided by negative 16. We'll get x is equal to 2. So looking for the length of CE, we know that CE is equal to 2. So it tells me the top is equal to 2. And that's okay though. It's, just means it's cutting it in half. And you can see that's true because we have these. This is 8 and 16, so that's a 2-to-1 relationship. All right. Okay. We can go down to the bottom and do the same thing here. So number 6. Take a look at number 6. All right. AB is 2. BC is 9. AE, which is this entire side, 36. And it says find the length of BD. So once again, this is a special case as well because I have, I'm looking for BC is spelled B, AE is 2, BC is 9, AE is 36. Okay, so for this one, this should not be BC. This should be AC because I don't have enough information to use to find using this side and this side. So we're going to change this so that this is equal to 9. So number 6, make sure you change BC to AC. Okay, and we're going to do the same concept here. Once again, if you look, I have top to bottom on this side, and here I have top to whole. So you have two options. One, we can talk about this being the entire x plus 2, and now I can do top to whole, or I can actually figure out that this is 27, because 9 plus 27 is 36, and now I can do top to bottom. So I'll let you figure it out either way. I'll do both. So x plus 2, the top, the whole, over the top, 2 is equal to the whole, 36, or 9. We'll cross multiply. So 72 is equal to 9x plus 18. Take away 18 from both sides. We should get 54. Is equal to 9x. Divide that by 9, and we'll get 6 is equal to x. And if you had done it the other way, you could have done 2 over x is equal to 9 over 27. We're going to get 9x is equal to 54, and you can see that we're right at that step right there. Okay? Either way will work. For number 7, just so you get a little bit of practice, we have triangle ABC. So you can just draw yourself a triangle. I usually draw one that looks like this. Okay, you can kind of see it. So I A, B, and then C. Now it says CE is parallel to AC. So my AC is here. So I'm going to draw a line that cuts through this way. And this is lines D and E. Now where is D? It says D is on AB. This means D is over there. E is on BC. So E is over here. And this is parallel to this. So in my drawing, I don't know exactly where this is going. So just label accordingly and then you can solve. So it says AD is 6. DE is 7. AC, this side, is 21. And they want you to find AB, which is we don't know, right? So same thing. So we can do, what we want to do here is focus on the fact that we're using our two triangles. This is one of them, and our big one is the bottom one. The problem we're going to run into is where the 6 is. Because the 6 is down here, we actually need BD up top. And so we need to remember that that turns out to be x minus 6. And now I can do the small triangle to the big triangle. Okay? And I'll leave you guys to do that one as well. All right. Next topic is on midsegments. What's the midsegment of a triangle or a figure? So midsegment's pretty easy in triangles. In terms of a triangle, the midsegment is when you connect the midpoints of the two sides of a triangle. And all that happens is this segment becomes parallel to the base, and it becomes half the length. That's it. Okay? Usually they like to ask questions about like finding the length of the big side, or like question 2 down here, what's the perimeter? So you can kind of use that knowledge to your advantage. So let's take a look at number 1. AC is 10, BC is 14, so this whole side is 10. Okay, BC is 14, and AB is 18. And they want to know what are the lengths of FC, FE, and CE, and then what is true about the triangles. So if this is 18, this side across, if it connects the midpoints, and it says they're midsegments, that means this is 9, half of this is 7, half of that is 5. Now keep in mind, if this is the midpoints, these sides are also 5 and 5, 9 and 9, and then 7 and 7. And so what can you tell me about the 4 triangles being formed? Well, if you notice, they all have a side length of 5 in them, a side length of 7, and a side length of 9. So we know that these 4 triangles are actually congruent, flashing, using side, side, side. All right, give the advantage to that one. So just keep that in mind for yourself, that the lengths of each of the parts here is cut in half, and then these segments, like CE, would be equal to FD there. All right. Number 2, we know that the perimeter is 36, and the key thing here is it says that this is an equilateral triangle. Once again, that these are the midpoints, so we know that this is a midsegment. So if we have an equilateral triangle of 36, that means that each side has to have a length of 12. So if I want to know the length of EF, and this is a midsegment, it's just half, so EF is equal to 6. Number 3 right next door, it says DE is 7. The length of here, AB, is 10. BC is 13. They want the perimeter. Remember, this is just doubled, so it's just 10 plus 13 plus 14, which is just 30.
37.
37, good job, Al. All right. And then this is the midsegment of a trapezoid. So in the midsegment of a trapezoid, it's almost like doing a triangle, right? Where the top part of the triangle, this piece right here, actually has a length of 0. So really what you're doing is you're adding 0 plus 20 divided by 2 is 10. Here we have a length that's not 0. So all we're going to do is that the midsegment is the average of the bases. We add the top, 26, plus the bottom, 40, and we divide it by 2. That's equal to the midsegment. All right, so this will be 66 divided by 2, which is indeed 33. And now you can get an idea why those numbers are there, okay? So it's just the average of the bases. So if you go down to number 4, once again, it tells me that these two lines are parallel, which is making this a trapezoid, and it mentions that these are the midpoints, which makes it a midsegment. So if RS is 30 and XV is 44, how do I figure out the length of this guy? Now here's a little leapfrog tip that I like to use here, which is however you get from one base to the midsegment, you have to do the exact same thing to get the other to the base. So if I have to add 14 to get from there to there, I have to add 14 to get all the way down to here. And so if I add 14 to 44, I will get 58, and that's my answer. If you want to do it algebraically, it will be 30 plus x over 2 is equal to 44. We can cross multiply 30 plus x is equal to 88. And then you can see how 58 comes about there. Okay? Same idea. Whatever you do to get from here to here, if I'm adding, you can see I'm adding 28. I do that half amount. Half of 28 is 14 to get from one base to the midsegment. So you can, if they give you numbers, you can use the leapfrog method. However, if they do not give you numbers and they give you something like number 5, which is algebraically, we're kind of stuck having to do this algebra, like setting up an equation and solving. So we have x plus 7 for the small base. We have 3x plus 11. Be careful you don't label that one. And we have 25. Without numbers, I can't just do the leapfrog method. What I need to do here is create an equation. So I know if I add the two bases and divide by 2, it's supposed to equal the midsegment. And so there's my equation. X plus 7 plus 3x plus 11 divided by 2 is equal to 25. Create a proportion, 25 by 1. Cross multiply, x plus 7. Oh, let's combine like terms. So that's 4x plus 18 is now equal to 50. I'll take away 18 from both sides. I'll get 4x is equal to, in this case it's 32, divided by 4, and x is equal to 8. Don't stop here. What do they ask you to do? Here, just to find the value of x, we're good to go. If it tells like the length of the segment, make sure you plug it back in. Okay, I'm leaving you guys these for homework. These 3 questions are exactly like the midsegment of a triangle. These parallel lines are cut into transversals proportionally. So you can either do top to bottom, top to hole, bottom to hole, any one of those things. So you guys are going to go about doing these guys. Careful on number 5. It should be a quadratic. Sorry for the lack of room on that one. So let's set that one up together, though. So we're going to do x over x minus 2, so left, top to bottom, equals right, x plus 4 over 9. So we're going to get 9 times x is 9x, and then we're going to get x minus 2 times x plus 4. So 9x is equal to x squared. Now, we're going to multiply the insides and add them together. So insides is negative 2x, outsides is 4x. Zoom in here. Okay? GIR, which is going to be plus 2x. And then on the outside is minus 8. I'll take 9x away from both sides. I get CLASS. X squared minus 7x minus 8. And now we can do our diamond. Remember, on the top is 8 times c, which is negative 8. The bottom is b, which is negative 7. And then I'm going to get negative 8, positive 1. So I get 0 equals x minus 8, or x plus 1. Get them equal to 0. X minus 8 equals 0. x plus 1 equals 0. I'll let you guys finish from here, and that'll be it. Okay, remember, we can't accept both answers here because we're talking about lengths of segments, so just keep that in mind. That should finish that off. If you have any questions, you guys can come and see me when I get back tomorrow. All right, guys, have a good one.